Let's consider an example. Let us have surface integral of first kind of x squared plus y squared plus 3z squared d sigma, and we have to calculate this integral by base of a cone, which is specified by the equation z is square root of x squared plus y squared, and it is cut by surface by plane z equals 1. We will have something like that. So we have cone and it is cut above by z equals 1. Now, to calculate the surface, we have to project it on a plane OX. Why? Why on OXY? Because if we try to project, for example, on OYZ, we'll have 2 points projected on same one point. So we would have to split this cone into 2 pieces, then project each one of them, and after that calculate integrals. But we can project it as a whole on OXY. So we need to find this line. This is an intersection of z equals square root of x squared plus y squared and z equals 1. So we can write a system of equations, and z equals 1. So from here, x squared plus y squared equals 1 is the equation of this circle of the line that is around this projection. Okay, now we have to calculate d sigma, which is square root of 1 plus z prime x squared plus z prime y squared dx dy. Z derivative by x will be x divided by square root of x squared plus y squared, and z prime y will be y divided by square root x squared plus y squared. So d sigma will be square root of 1 plus x squared over x squared plus y squared plus y squared over x squared plus y squared, and don't forget dx dy. And if we add these two together, we'll get x squared plus y squared over x squared plus y squared, and x squared plus y squared will be cancelled and we get 1, so 1 plus 1 is 2. As a result, we have square root of 2 dx dy. Now, integral by surface omega, x squared plus y squared plus 3z squared d sigma will be same as double integral by region D, x squared plus y squared plus 3x squared plus y squared. We substitute z with its equation and multiplied by d sigma, or square root of 2 dx dy. Now our projection is a circle. So, to calculate it, the best way is to switch the polar coordinates. Let us simplify it first a little bit. We will get 4 square roots of 2 double integral by d x squared plus y squared dx dy. If we switch to polar coordinates, we get 4 square root of 2 integral by d with wave. Rho, we have x squared plus y squared rho square, and multiplied by Jacobi matrix determinant we get j cube, rho cube, and d rho d phi. Next, because we have a full circle, angle goes from 0 to 2 pi, and because we have everything inside the circle, radius go from 0 to 1. So we get 4 square roots of 2, integral from minus pi to pi d phi, integral from 0 to 1 rho cube d rho, and we will have this integral will give us 2 pi, and this will give us 1 over 4, because we have rho cube will be rho power 4 over 4, and we substitute 1, get 1 over 4, we substitute 0, we get 0. So 4's are destroyed, and we get 2 square roots of 2 pi. This will be the answer. And also this value will be mass of this surface omega if we have density specified as x squared plus y squared plus 3z squared. Another example, we have a sphere x squared plus y squared plus z squared equals 3. And this is our surface omega. And we have other surface sigma 2z equals x squared plus y squared that cuts a hole in this surface omega and cuts off a piece. And we have to find area of the surface area of this piece. So this is a sphere, and this one is paraboloid figure. It's rotating parabola that cuts off a head of this sphere, a piece, upper piece of this sphere. Now we have to project this surface on a plane. To find this projection, we have to find equation its bounding line. And to do so, we have to make these two equations equal. We have to write them in a system, because these points are exactly points of intersection of these two surfaces. So x squared plus y squared plus z squared equals 3. X squared plus y squared equals 2z. So now we replace x squared plus y squared here with 2z. We get z squared plus 2z minus 3 equals 0. And solving this equation, we get z equals minus 3 and z equals 1. We cannot have x squared plus y squared being negative, so this solution is a no-go. And we have x squared plus y squared equals 2 is the equation of this circle. Now we have to find d sigma. This will be square root of 1 plus z squared by x plus z squared plus y, and everything is squared, dx dy. If we try to project on some other plane, we would have 1 plus, for example, we have here x, and we'll be having x prime z plus x prime y squares. So z prime x will be minus x over square root 3 minus x squared minus y squared. It is obtained from this equation. We have z from here. We find z from here and take its derivative. Z prime y will be minus y over square root 3 minus x squared minus y squared. Now we substitute everything in d sigma. We get square root of 1 plus x squared over 3 minus x squared minus y squared plus y squared 3 minus x squared minus y squared dx dy. And we get square root of 3 over square root of 3 minus x squared minus y squared dx dy. Now we substitute everything in our integral, surface integral of first kind. We have that area of this omega will be integral of first kind, surface integral of first kind d sigma, and this will be projected into region d o x y, square root of 3 over square root of 3 minus x squared minus y squared dx dy. Again, we have circle, so we have to switch to polar coordinates. We can move out square root of 3, and we will have doxy with wave, and we get 1 over square root 1 minus rho square multiplied by Jacobian rho d phi. Now again, we are putting our limits here, so angle will be from minus pi to pi, and distance will be from 0 to square root of 2 to the radius of this circle. We will have square root of 2 integral from minus pi to pi d phi, integral from 0 to square root of 2 rho d rho divided by square root 3 minus rho square. Now we get minus square root of 3 2 pi integral from 0 to square root 2 1 over 2 d rho square minus rho square plus 3 divided by same but under the root 3 minus rho square. So we just brought rho on the differential here and we got rho square. Now we brought minus out, we get minus rho square, and we added 3, so we get same as here in denominator. Now integrating this thing, we get minus 2 square root of 3 pi square root of 3 minus rho square from 0 to square root 2, which will give us 6 minus 2 square root through pi. 6 minus 2 square root 3 pi. This will be surface. This will be area of this surface.